So now that we have all this data, let's start looking at some properties of these cards. So for instance, I want to know how many students are there in this class. So let me start counting them. Okay. So let me quickly count.
How are you going to count it?
Let me just count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28.
You sure? 28?
1, 2,
we missed something.
3, 4, 5, 6, 7, 8. They are sticking.
Yeah.
10. It's not a very good way.
No, it's not a good way.
No,
Better way.
No, I think I should. I think I should separate them. Okay. So, 1, 2, 3, 4,
Hey, wait.
5. What?
Okay, good.
I have to start again.
No, this doesn't work. You need to do something else.
So if I get stuck in the middle, then I shouldn't have to start again, right? So let's do something. Let's write down.
Keep track somewhere.
So let me write down. So let me just mark each card, because I guess if I have more than this many cards, I might have to stop and continue. So what I will do is I will put a card down and then I will mark it, right? So I will say, for instance, this is 1, 2, 3, 4, and then
you might
when
want
I
to cross it. You might
I
want to
think
cross
I'll
it.
do this just to get bundles.
That's the normal way of doing it.
6, 7, 8, 9.
Cross it again.
10. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Okay, so there were actually 30 cards. I think I had counted 28. I think 2 were stuck. So now we are sure we have counted 30 cards, and we can check that we have 1, 2, 3, 4, 5, 6 bundles of 5. So 6 times 5 is 30.
All right. So that's.
But this is a bit tedious, because again, if we have 300 or 400, I don't know how many of these I would have to count.
Correct.
So maybe I should just count. But then if I count, I have to write it down.
You have to keep track. Yeah. Is
So
there a
let's
better way
just
to
count.
keep track?
Yeah, I think what we can do is we can just count and just keep writing the number and keep adding 1 to the number as we go along. Okay? So let's start that again. So maybe you move the cards aside and I will keep track of the count. So what I will do is I will keep track of a number and I will keep adding 1 to the number. So you count the cards by moving them, and I will keep track of the count, so that
you have to start somewhere, right? You have to start at somewhere.
So let's start with 0, right?
You
so
start with 0 because we have not seen any cards so far. Yeah, okay. So I am moving the first card.
Okay.
So I moved the first card.
So I will add 1 to it and I will make it 1.
So that is now count is now
1.
1. Okay.
Yeah.
So now I am moving the second card.
Okay. So I'll add 1 to that and I will now make count equal to 2.
2. All right. So I now move the third card.
Okay. So I will add 1 to it and now I will have 3. So I have 3. So I'll move to a new piece so that I have space. So I have 3 so far.
Okay. Here is the fourth.
Okay. 3 plus 1, that is 4.
Fifth.
Okay. 4 plus 1 is 5.
Sixth.
5 plus 1 is 6.
7.
So we were at 6. So 6 plus 1 is 7.
Okay. The next
7
card.
plus 1 is 8.
The next one.
8 plus 1 is 9.
The next one.
So we have 9 plus 1 is 10.
Next one.
10 plus 1 is 11. I guess we can keep going, and we know we have already counted 30. So when we get to the end, I guess.
So when you come somewhere here.
Okay. So say we have 4 cards left. So we would be at say 26.
26.
Then I would say 26 plus 1 is 27. 27 plus 1 is 28.
Next one.
28 plus 1 is 29.
And then the last
and finally, the last one I would have had 29. And then when I see the last card, I will get 30. Right. So now we are just keeping a number and we are just adding 1 to this number as we go along. So at any point we have the actual count. We don't have to go back and then count all the tick marks and the crosses and how many bundles of 5.
So there is a pattern that we are seeing here, right? Which I think is called an iterator.
Yes. Yes. This is what
programming.
Yeah. So this is what is called iteration. So basically, you go through the sequence of objects that you have, and for each object you keep a count. You do something with that object. Here we are just keeping count. So we are maintaining a count which starts with 0, and then as we go one object at a time, we keep incrementing that count by 1. So at the end, the count is actually equal to the total number of objects we have seen.
So we have two things that we have discussed here. One is the iterator. The iterator itself has a initialization.
Yes.
In this case, count equal to 0 is the initialization, and then at each step in the iteration, we are moving the card into another pile, and as we move the card into another pile, we are adding 1 to the count. That is the step. And then when do we stop this process?
Well, I guess we started with one pile and we are moving the pile. The second pile has those which we have already counted. So when we run out of things, we are done, right?
Yeah.
So all the things have been counted.
Everything has moved to another pile.
So the first pile is empty, the second pile has got everything. That's when
we stop. Are there better ways, or are there different ways in which one can pick cards from this? I mean, should we always pick the top card in this?
I guess it shouldn't matter, as long as each time you move one card from here to there, you can do it in any order.
So I can pick a random card like this and keep moving into a pile, right?
Yes, I think so. I mean, if you just count, it should definitely, because finally you are moving things from left to right, from one pile to another, and all that matters is that you move everything from here to there and you count once.
So I can pick a card randomly, I can pick the last card, I can pick the first card, I can go between the first and the last card.
Exactly. So you can go from, you can read it from beginning to end, you can go from end to beginning, you can do every alternate one and come back and do every alternate one, or you could just put your hand in. So supposing you have a sack of balls, for example, you could count it in the same way. You could
have no first and last.
You can put a hand into the thing, pull out the ball, put it in a second, and then it doesn't matter in what order you pull it out. When the first sack is empty and the second sack is full, you've counted them all.
So this is an iterator pattern, and there is a thing that we have kept on the side, an additional thing we have kept on the side. This is called a variable.
Yes. So this is a variable. So this we have called it, given it a name, count. So count is a quantity, and its quantity is a number which just keeps changing as we go along. So we started with an initialization, setting it to 0, and then as we went along, we added 1 to it, because that's what we were intending that variable to mean. It was intended to be the number of cards we have seen. So each time we see a new card, we add 1 to it.
So I presume that it's called a variable because its value keeps changing, unlike, for example, the name Sophia or the marks, mathematics marks, which is 89, which is not changing, right?
Exactly.
These are constants.
So this, as the process of our computation goes on, these values will keep changing. And that's what we are using somehow to keep track of
things. Keep track of things. And at the end, the value of it means something.
Yeah.
In the middle, it doesn't mean anything, but at the end of it, the value of the variable count is 30, which means something, and that meaning is the number of cards.
Actually, even in between, it means something, because it tells us how many cards we have moved to the side. But we are actually interested in this case in the final value. So we wait till the end, and then we look it up, and that gives us a summary of something about the card, some quantity about the cards. Okay, so last time we saw how to systematically count the cards by going from one stack to another stack and keeping track of variable, but surely counting is a very simple thing to do, and we should be able to do something more complicated than that with this information that we have on these cards. So what do you suggest is a good thing to check?
Suppose I want to find out what the average marks in mathematics is. There are these 30 cards, so they all have different maths scores. I want to find the average score of mathematics for all these students.
Okay, so the average would be that we have to then find out by adding up all the maths marks of all the students and divide by the total number of students, which we have already done. So we know the total is 30, so we don't have to count that again. But we just have to do some addition now.
We have to sum up all the maths marks and then divide it by the total number of students. Yeah, that's correct. Yes, that's what we have to do.
So again, we want to do this systematically.
Systematically, we want to sum all the maths marks. So do we use the same method that we did last time?
Yeah, so we can use the same iterator idea, except that this time, instead of keeping track of the count, we want to keep track of the total sum of all the maths marks, because at the end we want the total sum.
Yeah. So a good idea would be to start with a card. Let's call it sum.
Okay. So we will initialize it to 0.
0. Yeah. Okay. 0.
So
I shall read out the maths marks, and as I read it out, I'll move it into a different pile, like we did last time.
Yeah.
And you will keep track of the total maths marks we have seen so far, right?
Yes, absolutely.
Okay, so the first card is 68.
Okay, so let me just go slowly, because I have to add now. It's not just a +1. So I have now 68.
Now the second card is 62.
Okay, so 68 plus 62. So I have 130.
The next one is 57.
Okay, so that's now 187.
The next one is 42.
Oh, this is getting complicated. That's 229, I think. So we have seen 4 cards and we have 229 so far.
87 is the next one.
Okay. So that makes 316, right? So we can
go like that.
Yeah.
We can go that way
Yeah.
and keep adding 71, 81, 84 and so on.
Okay.
And if you go like this, keep on adding and we reach.
So then finally we come to the last card. So
we have 2099 and
then we have
last card is 72.
72. So our total now is 2171. So this is the total maths marks across the entire group of students. We know there are 30 of them.
Yeah.
So now we want to compute the average. So we have that the sum is 2171 and the count is 30. So we divide these two and we get 72.36666. Okay. So this is the average maths marks of the entire class for 30 students. So we added up this maths marks systematically by going through all the cards, and then when we got the total, we had already counted that there were 30,
round we had already counted
30 students. So now we divide that and we get the average.
Okay.
So instead of adding up just one at a time, we are actually adding up some information which is on the card. So we are actually.
So we have another variable which is sum.
Yeah.
That we kept track of. The sum variable basically, instead of just incrementing, we are accumulating the value of mathematics in the sum variable.
Exactly.
Is that so? Then basically at the end of the iteration, over 30 cards, we got the total value of the mathematics, and then we computed the average by dividing the two variables, and then we divided the two and we got the average mark. Is it possible that instead of doing two iterations, one for count and the other to find the sum, we could do both in a single iteration?
Yes, I mean, I guess so, because what we could do is we could just have, to begin with, we could say keep track of both quantities. So we can say count is 0 and we can say sum is 0.
And then as we go through the cards,
then when we see the first card, we make count is plus 1 and say,
sum
say 72 or whatever the maths marks, and then each time we add 1 to the top and the actual marks to the bottom, and so we keep track of both quantities
at the same time.
And the end
so in a single iteration, in a single round, we will be able to at each step keep track of two variables, one is count and the other is sum. At the end of it, you will get the total number of cards in count and the sum of all the mathematics marks in sum, and then you could divide one by the other and get the average.
Yes, and we could have also done this for another subject. We could have done physics at the same time, for instance.
Oh, we could have kept. So that means that sums. We can keep track of.
Yeah, so we could have had a mathematics sum and a physics sum.
Three variables.
For instance. So any number of variables that we want to keep track of,
we could
keep track of, as long as we make sure that we systematically update them with each card. At the end, we can do all of this overlapping in one iteration.
Right.
Okay.
So the pattern we are seeing here, the important pattern we have seen here is iteration, which has an initialization step. In this case, putting the variables to 0 was the initialization step, and at each stage we are moving the card into a different pile and updating the value of these variables, right, depending on what we have seen on the card. And then at the end of it, and the end basically is when all the cards are exhausted. At this stage, we can basically take all the variable values and do some operation on them.
Correct.
In our case, we did the computation of average, dividing one by the other.
So the last two examples, we did iteration over the entire stack of data and we kept track of some quantity.
Yeah.
But sometimes we are only interested in specific cards or specific items which are special to us and not in all the items. So for instance, here we have this data which consists of words from a paragraph. So each card has one word on it, and if you remember, it has the word, it has the type, whether it's a pronoun or noun or a verb or an adverb, and it has a number of letters in the word. So supposing we have the stack, and what we want to do is count the number of verbs in it. So we are only interested in some cards, those cards where the word is a verb.
Okay. So which so we should use the same method, which means that we go through the cards systematically.
Yes, but maybe we can just do something simpler. Maybe we can first go through the cards and pull out all the verbs.
Take out all the verbs?
Yeah.
Okay.
And then we can just count it, right?
Okay. So let me inspect the cards. So the first one is it, which is a pronoun. So I put it in one pile. The second one is a verb.
Yes.
So I should separate the verbs.
Yes. So keep all the verbs separately and everything else separately.
Okay. So I am moving this here, this here, this is going here. This also is a verb, was.
Yes.
So this comes here.
Adjective. Preposition. Verb. Put it down.
Okay. His is a pronoun. His is a noun. He is a pronoun. considered is a verb.
Verb, yes.
Okay. Monday is a noun. Speciality, unpleasant. In the calendar, after the delicious freedom of Saturday and Sunday, it was.
Was is the verb, yes.
Okay. Difficult to get. Here's another verb, right? Yeah. Into the Monday mood of work and discipline, he shuddered.
Shuddered
Oh,
is a
shuddered is a
verb.
verb. Sorry.
Yes,
Yes. So that should go here. At the very thought of school, the dismal yellow building, the fire-eyed Vedanayagam, his class teacher and headmaster with his thin long cane. That's it.
Okay,
huh?
that's it. Okay.
So,
we went through
we've
the
got
whole-
all the verbs. We
Okay.
separated the verbs.
So now we'll have to count the verbs. So we would have to do our usual
So
thing.
this,
of-
is this thing, I mean, I guess there is a name for this, right? Because you have taken out some subset of it. So
yeah.
this is a name for this in programming. I mean, what do we call this?
So it's like a bit like when you pour tea out of a pot and the leaves stay behind. So you want to
Okay.
keep some things.
So it's
this
filtering.
so this is called filtering.
Filtering,
So basically
filtering.
you take your data and you pass it through a filter, and anything which is caught by the filter stays behind, and all the other things pass through. So here
Okay.
the filter was to catch all the verbs, and then we left all the other cards through the filter, and we are not really interested in them. We are only interested in what is caught by the filter.
Okay.
Right? And now what we wanted to do first of all was to just count this. So we basically now we have collected these things and we have to separately count it. So we would do our usual thing of saying 1, 2, 3, 4, 5, 6, 7.
Keeping track, I guess, in your count variable.
Yeah. So basically we have filtered it and then we are counting, but we could also do this while we don't have to separately count this, right? We could have counted it while we were filtering. So we could have done this kind of iteration that we were doing selectively instead of doing it for every card.
So how do we do that? I mean, just
So
just
if
so
we
that we can
just
illustrate.
put it here, say in the middle, let's do something else this time. So let us do not verbs, but say pronouns.
Okay.
So let's count the pronouns. Right. So I will keep a card.
So you will keep
count.
but this count means sort of same.
Yeah, so this is the pronoun.
Earlier the count represented the total number. Now this count means something else.
Yeah. So now this is just
variable
a pronoun count.
pronoun count.
Okay, and it's initially 0.
It's initially 0. So I should move the cards one at a time
Yes.
to another pile.
Yes, and whenever
But
you
I'm
see
not
a,
separating it into 2 piles.
Yeah.
I'm just putting it all in a different pile, right? One
Yeah.
by one.
and whenever you
So-
see a pronoun, tell me, and I will increment this.
Okay, I shall do that. Yeah. So we have all the verbs which we found earlier. So this is a noun. This is a noun. This is an article. This is a noun. It's an adjective. It's an adjective. So we found the first pronoun.
Okay, so I make 0 into 1.
Okay. Then a preposition, a noun, a conjunction, a noun, another pronoun.
Okay, so now I make the 1 into 2.
Okay. Here's a noun, adjective, article, noun, adjective, article, noun, preposition, adjective, preposition. Here's another pronoun.
Okay, that's 3 now.
Noun, adverb, article, preposition. Here's a pronoun.
Okay, 4.
Noun, conjunction, noun, preposition, noun, conjunction, noun, preposition, noun, adjective, article, preposition, noun, article, preposition, adjective, adverb, noun. Here's another pronoun.
Okay, 5.
Noun, pronoun,
Okay, 6.
preposition, adjective, noun, verb. Finally, here's another pronoun.
Okay, so we have 7 pronouns.
So we have a pronoun count, and this time we did not separate out. We did
Correct.
not filter it.
Yes.
But I guess there is filtering going on here also.
Yeah, so this is like a filtered iteration. So it is
It's
kind of
iteration with a filter
yeah,
inside it,
correct,
right?
right. So we are overlapping in the. So earlier we said we could overlap 2 different counts, like a count and a sum. Now we are saying we can do a overlapping of a filtering and a count. So we are counting, but only those which are filtered. And I think we can actually do 2 filters at the same time, right? So supposing we had this, and we also wanted to count the verbs.
We could start with both of them equal
Right?
to 0.
So we could start with both. So let's just see, maybe just to we'll just start it off. We won't do the whole thing, but we'll just do this. So supposing we have the verb count, and then we have the pronoun count.
Equal to 0, both. I guess.
Right. So, both are initially 0. And now what we do is when we see a pronoun.
So, we see a pronoun. So,
Yeah,
you will
so
add
then
to
we
the
add
pronoun
to the
count.
pronoun count.
Now, I saw a verb.
So,
you will add to the verb count. Here's another verb.
So, you will add to the verb count.
Here is a noun. Now
So,
what
I
do
will
you do?
add to nothing.
Nothing. You will not add to anything. Okay. Here's another noun. Here's another noun. Here's an adjective. Again, nothing. Preposition. Nothing. Pronoun.
2.
Okay. Noun. And so on. We can do
Yes,
the same thing.
exactly. So, now we are basically either we in this
When
case
you-
everything is either a verb or a pronoun or something else. So, if it is something else we do nothing, we do not adjust any of these counts. If it is a verb we
Add it to the verb
increment
count.
the verb count, we add +1 to the verb count. If it is a pronoun we add +1 to the pronoun count. And of course, we could also do it with 3, we could do nouns, pronouns, verbs, we could do adjectives, pronouns. So, we can do as many of these in parallel, just like we said earlier we could keep track of maths marks and physics marks, or maths marks and physics marks and some other marks, right. So,
here we have two variables, the
Yes.
verb count and the pronoun count, and so what we are doing is each card we are actually inspecting that card, and we are checking whether that card is a verb or a pronoun, or it might be neither verb nor pronoun.
yes,
So, these are the three possibilities. It can't be anything else.
Yeah.
So, it's either a verb or a pronoun, neither of them. So, if it is a verb, then we are adding to the verb count. If it is a pronoun, we are adding to the pronoun count.
yes,
And if it is neither, we are just ignoring the card.
exactly. Or we could have even kept a third count which was other,
Count.
right, and we could have done 0, 1, 2. Whenever we saw another, we could have added to
that.
And then we would have got across the 3, every card should either be a verb or a pronoun or another card.
So, if you add up finally at the end, all the 3 counts should add up to the number of cards.
Total number of cards.
Total number of
every
cards.
card should have fall into one of these 3.
One of these 3 categories.
Fall into one of these 3.
One of these 3 categories.